Welcome to Middle Class Matters. Today, the 15th June 2023, business news in English from Dr. M.V.'s allegation on CAG report on derailment in Indian Railways. This is part 8 series of this CAG report, that is on train accidents 3.1.2 train accidents. Railway Board issued directives in respect of definition and reclassification of accidents on Indian railways from time to time. According to accident manuals were formulated separately by the respective zones. There are two types of accidents. One is consequential train accidents, where major property loss or human life will be there, and other train accidents, all other accidents will be covered under this. As per 3.1.2 table, details of consequential train accidents, it is total accidents in 2017-18 is 74, 18-19 is 65, 19-20 is 58, 20-21 is 20, totaling for the last 4 years it is 217. It can be seen that out of 217 consequential accidents, the maximum accidents, that is 163 derailments, were due to derailments, which constituted around 75% of the total consequential accidents, followed by accidents due to fire, which was around 9%. Derailment of other train accidents. For total for 2017-18, 334, 18-19, 656, 19-20, 485, 2021 325, totaling to 1800. In the category of other train accidents, total 1800 accidents took place. The derailments accounts for 68%, that is 1229 derailments. Out of 2017 consequential and non-consequential accidents, 1800 plus 217. The accidents due to derailments were 392, 69% during 2017-18 to 2021. In view of the maximum accidents in the category of derailments, audit focus was on the accidents due to derailments. 3.2 Derailments on Indian Railways. Derailments are offloading of wheels causing detention or damage to the rolling stock or permanent way. 3.2.1 Causes of derailment. As per Indian Railway, a derailment may be sudden or gradual due to failure of one or more of factors related to track, train operations, mechanical or rolling stock, and signal and telecommunication. 3.2.2 Category-wise derailments. The total number of accidents due to derailments is derailment as percentage to overall accidents in 2017-18 is 63%, 2018-19 is 73%, 2019-20 is 74%, 2021 is 60%. On total accidents during the last 4 years, it is 69%. Analysis of 1129 enquiry reports, that is 81% of 1392 derailment accidents in 16 zones and 32 divisions revealed that the total damage or loss of assets was reported as Rs 33.67 crore in the selected cases of derailments. Audit also revealed that 23 factors responsible for derailments in the selected 1129 cases or accidents over 16 zones. The maximum derailments 395 were in engineering department, followed by operating department 173. Out of the 23 factors, the major factor responsible for derailment was related to maintenance of track, 167 cases, followed by deviation of track parameters beyond permissible limits, that is 149 cases, and bad driving or overspeeding, 144 cases. 3.3 Analysis of accident enquiry reports. The main objective of an inquiry is to ascertain the cause of an accident and to formulate proposals for preventing their occurrence. In the process, it is ascertained if any inherent defect exists in the system of working or in the physical appliances such as tracks, rolling stock, and other working apparatus. Such measures for recycling the defects and irregularities, measures for rectifying the defects and irregularities are then proposed based on the findings. As per the accident manual, the accident enquiries are classified as inquiry by CRS, major joint inquiry, minor joint inquiry, and departmental inquiry. As per safety framework in Indian Railways, all serious accidents shall be inquired into by the Commissioner of Railway Safety (CRS). All other consequential train accident shall be inquired by Deputy Chief Safety Officers from Safety Department to be nominated by the General Manager of the zones with the GM as accepting authority. Some of the incidents are also inquired into by a committee of senior scale or junior scale officers as decided by the respective divisional railway manager. Apart from safety department, the role of other departments in the zones are as follows. 1. Civil engineering department is required to ensure safe movement of passengers and goods on newly constructed lines, which demands constant vigil on this part. 2. Mechanical department is responsible for maintenance of rolling stock, including passenger coaches, freight wagons, diesel locomotives, DMUs, and cranes. The department also formulates plans for procurement of rolling stock, machinery and plant, and ensures safety and reliability of stock in train operation. 3. Operating department frames rules for working of trains based on optimal safety parameters and exercising control over the operations as per the rules so laid down. 4. Signal and telecommunication department is responsible for ensuring existence of proper mechanism for installation, operation and maintenance of related equipment for safe operation of trains. 5. Electrical department is responsible for installation, maintenance and upkeep of overhead electrical traction for safe running of trains on electrified routes on Indian Railways. 3.3.1 Leading indicators or factors arising out of accident enquiry reports. Every enquiry gives its findings about the causes of the accident, fixes responsibility and suggests measures to prevent accidents. The number of derailments attributable to each factor has been further categorized department-wise. The cases indicated below are combination of factors and not mutually exclusive. A. Engineering department. Defects in permanent way were identified as one of the factors responsible for derailments in 37% cases. The factors have been categorized in table number 3.3.1, that is risk factors identified in accidents reports, number of reports percentage, number of consequential derailments. 1. Other issues of maintenance of track 167, 42% and 33 is the number. 2. Deviation of track parameters beyond permissible limits 149, 37% and 22. Improper loading by engineering department 18, 5%, 1. Waterlogging, improper drainage on track or weak formation 10, 2% and 2. Bad layout yard remodeling required 17, 4% and 3. Existence of sharp curve 17, 4%, 0. Mechanization issues 16, 4%, 1. Deficiencies in new construction 14, 3% and 5. B. Mechanical department. The defects in wheel diameter variation and defects in coaches or wagons attributable to the mechanical department was the first major, that is 33% contributed to the factors responsible for derailments. This was one of the causes identified in 15% cases as per the details given in table 3.3.2. Factors responsible for derailments: mechanical deportment, risk factor identified in accidents, number of reports and percentage of reports. Wheel diameter variation and defects in coaches or wagons: 57-33%. Incomplete POH or sick wagons: 42 and 24%. Deficiencies in coach or wagon maintenance: 43 and 23%. All others contributes negligible portion. C. Loco pilots or mechanical and electrical deportment. The human error was the major factor responsible for derailments attributable to the loco pilots. This was one of the causes identified in 13% cases as per detailed in table 3.3.3. That is 1. Bad driving or overspeeding: 144, 96%. An invalid brake power certificate: 5 and 13%. D. Operating deportment. The factors responsible for derailments attributable to operating deportment constituted 24% cases of derailments as detailed in table 3.3.4. 1. Incorrect setting of points and other mistakes in shunting operations: 224 numbers and 86%. Poor working or failure of station master: 37, 14%. E. Signaling and telecom deportment. The major 74% factor noticed was system or technological deficiencies, visibility issues. The factors responsible are detailed in table 3.3.5. System or technological deficiencies or visibility issues: 20 cases, 74%. Inspection schedule not followed: 3 cases, 11%. Failure in attending scheduled maintenance: 4 cases, 12%. F. Electrical deportment. There were 10 N1 cases of derailments in electrical deportment, excluding loco pilots, in 4 zones. The major factor, 8 out of 10 cases, noticed was non-adherence of safety at worksite in Western Railway. Audit analysis of the accidents and causes of accidents as brought out in the inquiry reports revealed that in each accident multiple factors attributable were collectively responsible for the derailments. Slackness in supervision or inspection, training and counseling requirements was the main areas of concern highlighted by the inquiry committees in most of the cases across the zones. All-out efforts at the every level of staff and broader perspective at the highest level with proper coordination among all the departments is therefore required to fill these holes, to put strong layers of defense to prevent derailments. 3.4. Audit analysis using Swiss cheese model in Indian Railways. The causes of derailments on Indian Railways were analyzed in accordance with the Swiss cheese model. From the review of the derailment cases, the cascading factors of series of failures have been identified, which includes 1. Rules and Joint Procedure Orders JPOs, 2. Training and counseling of staff, 3. Supervision of operations, 4. Coordination and communication between staff of different departments, and 5. Scheduled inspections in the Indian railway system. These could be considered as the layers of Swiss cheese slices or defense barriers for prevention of accidents as depicted in picture below. Based on the results of the accident investigation, several factors that led to the derailments were obtained. These factors translated into Swiss cheese model and a straight line was drawn to connect one factor of each layer to obtain a conclusion. From the above figure, it can be concluded that most of the derailments occurred due to simultaneous failure of each of the 5 barriers. Examples of individual cases of derailments occurred due to simultaneous failures of each of the 5 barriers depicted in the picture or given in the table below 3.4.1. Please like the video, subscribe to the channel, give your comments, and thanks for watching.